find the remainder when 428 raised to 2024 is divided by 21. Now in JEE Main, the problem on remainder calculation is very common, right? In last few years, you will find that there are number of PYQ where we have one number raised to some large power, and if we divide that number by some other number, then we have to figure out the remainder. Now here, generally for those problems, you'll find that this base is a small number, right? But here in base we have 428. So the very first step will be that divide this 428 by 21 and see what is the remainder we are getting. So in that way you can reduce the base here. So if you divide 428 by 21, clearly you can see that 420 will be multiple of 8. So that means 428 we can write this as 420 plus 8, and 420 this is multiple of 21. So let us say this number is n. So we can write n as 8 plus 420 and this raised to 2024, right? Now if I expand it using binomial, then you will get 8 raised to 2024, and after that all the subsequent terms, right? The second term will contain 420, the third term will contain 420 square, and so on. So only this first term, which is 8 raised to 2024, that is not multiple of 420. All the other subsequent terms, they are multiple of 420, and hence they are multiple of 21. So therefore all of those numbers we can write as 21 into k, where k is some integer. And if you divide this number by 21, then you will get 0 as remainder, right? When you divide a number which is multiple of 21 by 21, then the remainder will be 0. So now this one we can neglect, and we have to focus on this 8 raised to 2024. So now we need to see that which exponent of 8 is either 21 plus minus 1 or some multiple of 21 plus minus 1. That means if I do 8 square, right, we have to figure out different exponents of 8. So if I do 8 square, we'll get 64, and 64 is 1 plus 63. 63 is multiple of 21. So that means now we have to write this number 8 raised to 2024 as 8 square raised to 1012. 8 square will be 64. 64 is 1 plus 63. So now 1 plus 63 raised to 1012. And now you can see that if I expand it using binomial, then we'll get 1. The next term will be 1012C1, this multiplied by 63. After that, the next term will be 1012C2, and this multiplied by 63 square. So you can see that all of these terms, right, the last term will be 63 raised to 1012. We do not even have to, once you practice a Bayesian problem, you can directly see the answer. So now all of these numbers, right, except the first one, all the remaining numbers, they are multiple of 63, and 63 is multiple of 21. So that means all of these numbers we can combine, and we can say that that is some multiple of 63 and hence multiple of 21. So therefore this number n, this will be of the form multiple of 21 plus 1, right? N is this number, n will be some multiple of 21 plus 1, and if I divide this number by 21, clearly the remainder will be 1. So that is the correct answer for this problem, right? So in this problem, first step was that decrease this base, right? Reduce this base 428. So for that, divide 428 by 21, you will get 8 as remainder. So that means we can write this number as 8 plus 420 raised to 2024. Expand it using binomial. Only this first term is not multiple of 21. All the other terms, they are multiple of 21. So we can neglect multiples of 21 because we are dividing by 21. And now we had to see that which power of 2 is either 21 plus minus 1 or some multiple of 21 plus minus 1. So 8 square is 64. 64 is 1 plus 63. So finally this number was multiple of 21 plus 1. And if you divide by 21, the remainder will be 1.